In 2016, the world was buzzing with news about an ambitious project unfolding in China. It was set to become one of the most complex yet groundbreaking feats ever accomplished in the country. This wasn't just any construction. It spanned underwater, on the water, and high above it. The only thing missing was building underground to complete the full spectrum of engineering challenges. Even without that, the obstacles were immense. This wasn't just any construction. It spanned underwater, on the water, and high above it. The only thing missing was building underground to complete the full spectrum of engineering challenges. Even without that, the obstacles were immense. But if there's one thing China has proven time and again, it's that no challenge is too great. Millions of tons of materials were submerged, and thousands of workers braved extreme conditions, using cutting-edge equipment designed specifically for this endeavor. Piece by piece, a revolutionary system took shape, each section setting new construction records. The result? A game-changing development that propelled one of China's most vital regions forward at an astonishing rate. The project began to take shape between two major cities in southern China, Shenzhen and Zhongshan. But does such a massive and costly undertaking really make sense for these two locations? Well, first off, this is China, where billion-dollar mega-projects are practically routine. And second, when you're dealing with cities that play a crucial role in the country's economy, major infrastructure upgrades aren't just beneficial, they're essential. Take Shenzhen, for example, a prefecture-level city whose significance is undeniable just by looking at its economic standing. Among Chinese cities, Shanghai leads as the most developed, followed by the capital, Beijing. And right behind them? Shenzhen. By 2022, Shenzhen's GDP had skyrocketed past 3 trillion yuan, approximately $482 billion, surpassing entire countries like Malaysia, Vietnam, and Denmark. In fact, its economic output rivals that of the UAE. But its influence doesn't stop there. Shenzhen ranks among the top 10 cities with the largest economies globally, placing 8th in overall competitiveness and standing as one of the world's most powerful financial hubs. It even claims the 6th spot for the highest number of billionaires, with an impressive 84 ultra-wealthy residents, according to the Hurun Research Institute. Shenzhen also boasts several other impressive advantages. It ranks 2nd in the world for the number of skyscrapers and 19th for the number of research institutions, among many other accolades. The media has even dubbed it China's Silicon Valley. Simply put, Shenzhen is what's known as an alpha city. And that's not just a casual label. This designation comes from the British Analytical Centre, the Globalization and World Cities Research Network. What's even more remarkable? Less than a century ago, this global powerhouse was nothing more than a small fishing village. Now, it stands as one of the largest megacities on the planet. But let's not get too carried away. Shenzhen's long list of records could fill an entire 20-minute video on its own. Now that we've covered Shenzhen, what about its neighbor, Zhongshan? Zhongshan is one of the few Chinese cities named after a person. It was originally called Xiangshan, but in 1925, it was renamed in honor of Sun Yat-sen. Unlike Shenzhen, Zhongshan doesn't often appear in top global rankings, and with a population of just 3.1 million, it's overshadowed by its bustling neighbor, which houses nearly 13.5 million residents. Its GDP is also much smaller, around $50 billion. Unlike Shenzhen, Zhongshan doesn't often appear in top global rankings, and with a population of just 3.1 million, it's overshadowed by its bustling neighbor, which houses nearly 13.5 million residents. Its GDP is also much smaller, around $50 billion. However, the Chinese government has big plans for Zhongshan, aiming to transform it into another major tech hub. The city is rapidly developing its industrial sector and establishing national-level research centers. However, the Chinese government has big plans for Zhongshan, aiming to transform it into another major tech hub. The city is rapidly developing its industrial sector and establishing national-level research centers. One of its key assets is the Zhongshan National Torch High-Tech Industrial Development Zone, which, as of 2021, had attracted 430 foreign invested enterprises, including 20 from the Fortune 500 list. Major corporations like Canon and Casio have already set up operations there. Zhongshan is also home to one of China's largest seaports, primarily handling bulk cargo and container shipments. Its strategic location and growing economy make it an attractive destination for both foreign investors and residents, especially those from nearby Shenzhen. It's clear that these two cities share a strong and dynamic connection. Every day, goods and people travel between Shenzhen and Zhongshan. Many residents live in one city but work in the other. However, a major obstacle stands in the way: the Pearl River. Without a direct route, crossing between the two cities requires a bridge or ferry. However, a major obstacle stands in the way: the Pearl River. Without a direct route, crossing between the two cities requires a bridge or ferry. To solve this, several bridges were built, with the most notable being the Human Bridge. Completed in 1997, it quickly became a crucial link. At the time, its 2,900-foot mainspan made it the longest bridge in China. The total length stretches 11,900 feet, supported by 5 massive concrete sections. Its deck was specially designed to withstand winds up to 200 feet per second, a necessary feature given the region's frequent typhoons. Beyond its engineering feats, the Human Bridge marked a turning point for China. It was the first large suspension bridge entirely designed and built by the country. This project signaled the start of China's modern bridge-building era. However, as Shenzhen and Zhongshan grew rapidly, the Human Bridge alone became insufficient. China's economic boom of the late 1990s led to a surge in population, industry, and transportation needs. It became clear that a more advanced solution was necessary. When the Human Bridge was built in 1997, Shenzhen had a population of just 3.5 million. Today, that number has soared to 13.5 million, an increase of 10 million people. Meanwhile, Zhongshan's population grew from 945,000 to nearly 3.1 million. And these figures don't even account for the many smaller settlements nearby. When the Human Bridge was built in 1997, Shenzhen had a population of just 3.5 million. Today, that number has soared to 13.5 million, an increase of 10 million people. Meanwhile, Zhongshan's population grew from 945,000 to nearly 3.1 million. And these figures don't even account for the many smaller settlements nearby. It's clear that the bridge, originally built to accommodate a much smaller population, was never designed to handle such massive growth. As the number of residents increased, so did businesses, stores, and the demand for cargo transportation between the cities. On top of that, travel time from Zhongshan to Shenzhen had stretched to nearly 2 hours, an unacceptably long commute by Chinese standards. A faster, more efficient solution was needed. That's why, in 2016, cargo ships began appearing on the Pearl River again, carrying construction materials, steel, and everything required for a new $5 billion mega project. That's why, in 2016, cargo ships began appearing on the Pearl River again, carrying construction materials, steel, and everything required for a new $5 billion mega project. There was just one problem. No suitable land existed for the project. But China had already mastered the art of land reclamation, as seen with the Hong Kong airport. So, engineers devised a plan to construct 2 artificial islands as the foundation for this massive new infrastructure. The first artificial island, known as the Eastern Island, is located just south of Shenzhen Bao'an International Airport. Now, anyone arriving in one of China's most advanced cities is welcomed by a stunning man-made landscape spanning an impressive 3.7 million square feet. Even those with an eye for aesthetics will be captivated, as the island looks like something straight out of a sci-fi film. On the other hand, the second island, the Western Island, is a similar structure but much smaller, covering just 1.4 million square feet. This size difference is due to its location, as it sits almost in the middle of the river, making construction significantly more challenging. Transporting materials and building in such an environment required a different approach compared to the eastern island near the shore. Environmental considerations played a crucial role in the project as well. Constructing in the middle of a river naturally produces more debris, so engineers minimized the use of materials to reduce the environmental impact. But that wasn't the only innovative aspect of the project. Incredibly, China managed to complete an artificial island equivalent to 19 football fields in just 4 months, an achievement that wouldn't have been possible without cutting-edge technology. The project team designed a specialized device that allowed them to drive 57 massive steel cylinders into the seabed in record time, reducing both labor and environmental disruption. This efficient method helped to maintain the ecological balance of the Pearl River. If you're wondering why these artificial islands were necessary, their primary purpose is to serve as key infrastructure points. They house emergency rescue docks and power supply stations, ensuring the smooth operation of the bridge project. Additionally, the eastern island serves as an entry point to the underwater tunnel, while the western island allows a seamless transition from the tunnel to the bridge sections leading toward Zhongshan. Yes, you heard that right. To travel between these two cities, you'll actually have to drive underwater for part of the journey. Now, take a look at this. Not just the excitement of people celebrating a finished project, but a moment of triumph for Chinese engineers. They are marking the opening of a state-of-the-art factory, specifically modernized for one of the most challenging engineering tasks, assembling the enormous underwater tunnel sections that would rest on the bottom of the Pearl River. Here's one of those massive tunnel tubes. It stretches an incredible 540 feet in length, spans 150 feet in width, and stands 35 feet tall. But what truly highlights the complexity of this project is its sheer weight. Each segment displaces a staggering 80,000 tons, making it even heavier than China's Liaoning aircraft carrier. And they didn't just make 1 or 2 of these. Many were needed to complete this incredible underwater passage. But how did they transport and install these enormous structures with pinpoint accuracy? You might think they needed an entire fleet of ships, or that making smaller segments would have been easier. But every step was carefully planned. A specialized floating factory, staffed with hundreds of workers, transported each tube over a distance of 31 miles, navigating through 7 different shifts in the riverbed. Once in position, workers precisely lowered each segment and secured it in place. And it wasn't just about placing the sections on the riverbed, they needed a solid foundation. The solution? An underwater 3-dimensional printing system. This cutting-edge innovation not only made construction more efficient, but also helped reduce costs and speed up the entire process. It's no surprise that this massive construction project faced its fair share of challenges. How could it not? With such a complex operation, every step required extreme precision. Divers played a key role underwater, while the control team aboard the floating factory remained on high alert. But despite the difficulties, the record-breaking tunnel is now complete. And this isn't just any tunnel. It's the longest 2-way, 8-lane underwater tubular tunnel ever built. Spanning over 3 miles, it also holds the record for being the widest underwater tunnel, reaching an incredible 182 feet across, including its protective shell. But that's not all. The newly constructed route between Shenzhen and Zhongshan has set multiple engineering records, some of which are truly groundbreaking. Driving through this tunnel is an impressive experience on its own. But looking deeper, the innovations make it even more fascinating. Take the lighting system, for example. At first glance, it might seem like a basic feature, but these smart light strips actually change color in real time based on temperature and traffic flow. In case of an emergency, they act as built-in navigation, guiding drivers to the nearest exits. An essential feature, especially for those with claustrophobia. But safety doesn't stop there. The tunnel is equipped with an advanced fire suppression and smoke extraction system, ensuring a secure environment. And since this is China, of course, there are robots. Underwater, 14 robotic patrol units constantly monitor pipes, cables, and even traffic incidents. If something happens, these robots can issue real-time alerts through built-in loudspeakers and transmit live footage to a remote command center. And here's another record. This tunnel features the widest multi-fold waterproof seal ever used, ensuring a secure connection between the tunnel and its submerged sections. But this project isn't just about the tunnel, because while it's an engineering marvel, the bridges above it are just as impressive. This engineering marvel isn't just about the underwater tunnel. There's also an incredible journey above the water. The total length of the two bridges connecting the artificial islands to the mainland spans 27 miles, with 10 miles stretching directly over the sea. This ensures a continuous route between the two cities while setting new engineering standards. While the bridge isn't a single continuous structure due to the underwater tunnel, it still holds impressive records. The main span of the Shenzhen-Zhongshan Bridge stretches 5,460 feet, making it the longest sea suspension bridge with box girders. It also boasts the highest navigational clearance of any sea bridge and the tallest bridge deck in the world at 300 feet above the water. The roadway itself covers 4 million square feet, and while that may not break records, its hot epoxy asphalt surface is a major innovation. As for the towering supports, they stand between 700 and 885 feet tall, comparable to a 90-story skyscraper. From its massive underwater tunnel to its record-setting bridges, this project is a true testament to modern engineering. Before construction even began, the biggest concern was the main towers. The river's harsh conditions, combined with the challenging marine environment and frequent typhoons, made this project extremely risky. To counter these threats, China developed a groundbreaking solution. In 2018, engineers designed a smart construction machine capable of handling steel rod processing, concrete distribution, installation, maintenance, and monitoring, all while being fully mobile. Remarkably, it took just a year and a half to develop, and by 2019, it was ready for action. Thanks to this innovation, project timelines remained on track. According to the team, this machine built towers 1.5 times faster than traditional methods. More importantly, it significantly improved worker safety, reducing the need for high-rise labor by 60%. It also ensured better structural integrity by preventing shrinkage cracks in the concrete. Supporting the towers is a high-tension cable system, with each cable capable of withstanding over 140,000 tons. To ensure reliability, every cable underwent rigorous lab testing before installation. The bridge is designed to withstand extreme weather, including typhoons with wind speeds of 275 feet per second or 187 miles per hour. To put that into perspective, it could endure a storm as powerful as Hurricane Irma, the Category 5 hurricane that struck the southwestern United States in 2017, where peak wind gusts reached 177 miles per hour. But what happens if even stronger winds strike? Would drivers lose control? And what about reckless drivers who could pose a danger? Engineers addressed these concerns with reinforced safety barriers. To ensure their strength, they conducted rigorous crash tests, using not only regular vehicles but also large buses to simulate maximum impact. The results confirmed that the barriers could effectively absorb collisions, ensuring safety for both drivers and the bridge itself. Did you know that infrastructure projects have their own equivalent of the Nobel Prize? It's called the George Richardson Medal, and in 2024, it was awarded to the Shenzhen-Zhongshan route in recognition of its groundbreaking engineering and impact on transportation. Of course, for regular commuters, the most important thing is how the bridge improves travel. It features 8-lane roads designed for speeds of up to 62 miles per hour, allowing for smooth and efficient travel. But beyond speed, the real benefit is the drastic reduction in travel time. Before the bridge tunnel system opened in 2024, the journey between Shenzhen and Zhongshan took nearly 2 hours via the older human bridge. Now, it takes just 30 minutes. This major improvement drew immediate public attention, leading to an overwhelming surge of traffic. Shenzhen quickly launched intercity bus routes to capitalize on the new connection. However, the initial excitement resulted in heavy congestion, forcing commuters to choose between long waits or taking the older 2-hour detour. Eventually, the hype settled, traffic stabilized, and today, around 100,000 vehicles use the bridge daily. In just the first month, over 3 million cars had already taken advantage of the new route. This engineering marvel not only set records, but also transformed transportation in the region, reinforcing China's position as a leader in infrastructure innovation. The impact of this engineering marvel was felt immediately across the region's transportation network. Traffic on the older Human Bridge saw a 26% decrease, while the more distant Nansha Ferry crossing, located farther from Shenzhen and Zhongshan, experienced a 7% drop. Interestingly, instead of merely redistributing existing traffic, the new route actually increased overall travel demand. With congestion reduced, more people took advantage of the faster connection, making travel between the two banks a daily norm. As a result, total traffic across all Pearl River crossings surged by almost 15% year over year. This surge in movement translated into economic benefits. The $5 billion investment and 8 years of construction proved to be a catalyst for regional growth. By improving accessibility and reducing travel time, the project played a vital role in strengthening one of the world's richest and most densely populated economic hubs.